Sedimentary rocks form in a variety of environments on Earth's surface. Geologists study modern environments to understand how rocks form today, and they use these data to better interpret ancient environments as preserved in the rock record. We can read these rocks to decipher past climates, reconstruct former landscapes, and predict where to search for oil and gas resources.
This lesson has two learning objectives. We will describe the three major classes of sedimentary rocks, discuss their formation, and explain where they are forming today on or near the Earth's surface.
There are three classes of sedimentary rocks: clastic, chemical, and biochemical sedimentary rocks. We can differentiate them on the basis of the materials that compose the rock and the processes by which they form. Let's look at the first category, the clastic sedimentary rocks.
There are three steps in the formation of clastic sedimentary rocks. Clastic sediments are composed of fragments of rock. In fact, a clast is a technical word geologists use to describe a rock fragment. These fragments weathered from pre-existing rocks to form sediment of various sizes. This sediment is then transported away from its source area, and finally it is deposited and converted to form a new rock through lithification.
Rocks break down on Earth's surface to form sediment. This sediment may be composed of the rock's constituent minerals, which may then be physically or chemically broken up further to form even smaller grains or other minerals. We can see the individual feldspar minerals weathering out of this igneous rock, and notice the grains of sediment at the base of the outcrop. Now we need to erode it or transport it away from its source.
Sediment is eroded by transportation agents such as streams. For example, this river in Alaska is carrying a high sediment load as reflected by the muddy color of the water and the sand and gravel bars within the stream channel.
Sediment is also eroded by winds. Much of the topsoil of western Oklahoma and northern Texas was blown away during the Dust Bowl era in the 1930s. And we see similar dust storms known as haboobs today in drought-stricken western states. Elsewhere, dust and sediment from the Saharan desert may be transported across the Atlantic Ocean to Central and North America.
Finally, sediment of all sizes can be transported by glaciers. For example, the dark surface on the Reed Glacier in Alaska reflects the sediment that is exposed as the ice melts. If we look closely at the glacier, we can see layers of sediment encased in the ice.
So sediment is first weathered from rocks during the breakdown phase, next it's eroded and transported, and finally it's dumped or deposited in some location. Sediment is deposited when rivers enter the ocean, or when wind velocity decreases, or where glaciers melt. As more and more sediment builds up, the material at the base of the pile is compacted. Compaction squeezes out spaces between grains and pushes the grains closer together. Finally, chemicals precipitate out of water to cement the grains together and form a rock.
Each size of clastic sediment produces a different type of clastic sedimentary rock. Sometimes the link between sediment and rock are obvious, such as the lithification of sand to form sandstone. Other times, the names of the sediment and the resulting sedimentary rock are quite different. For example, conglomerate forms from rounded gravels, and clay-sized particles are consolidated to form shale.
The second major category of sedimentary rocks are the chemical sedimentary rocks. Imagine that you left a pan of salted water on the stove for long enough. The water would evaporate away, leaving the salt behind. Essentially, the same thing happens in nature as water evaporates, leaving any dissolved minerals behind. For example, ancient Lake Bonneville covered much of Utah 10,000 years ago. Most of the lake dried up, leaving the flat lake bed covered in a layer of salt.
Most chemical sedimentary rocks form as a result of precipitation from seawater, but minerals are also dissolved in lesser concentrations in groundwater and freshwater lakes and rivers, and are also concentrated in hot waters associated with thermal features such as hot springs and geysers. Travertine, a type of limestone, forms when minerals precipitate in places where warm chemical-rich waters come to the surface.
Biochemical sedimentary rocks also result from precipitation, but this precipitation occurs due to the actions of organisms, typically marine organisms. Think shellfish, for example. They form their shells by causing minerals to precipitate out of seawater. The same process can happen for microscopic marine organisms, like coccolithophores. Coccolithophores are composed of tiny plates known as coccoliths. Even though you couldn't see one of these with your naked eye, if you get enough of them together, you can create spectacular chalk cliffs. such as those along the southeast coast of England.
Other marine organisms, such as corals, clams, and oysters, also build shells that eventually form biochemical sedimentary rocks. Plants can also end up as rocks. For example, vegetation in tropical swamps can be compacted and compressed to form coal.
Finally, we can summarize what we have learned today to recognize that different types of sedimentary rocks leave clues to the past environments on Earth. Clastic sedimentary rocks such as conglomerate, shale, and sandstone can form in environments such as mountain streams, swamps, deltas, deserts, and beaches.
Chemical sedimentary rocks are formed in environments such as lagoons and groundwater systems. Biochemical sedimentary rocks such as limestone or chalk form in marine environments, while coal indicates the former presence of tropical wetland conditions.
We had 2 learning objectives for today's lesson. How confident are you that you could complete both of these tasks? Okay, that's it for us. We're off to use some dead coccolithophoros to write some stuff on chalkboards.